This week is a lot about just triangles. You guys are going to see lots of different triangles and shapes. So really this last couple of weeks has really just been about geometry. Okay? We don't have a geometry course anymore, but basically all our classes have both geometry and algebra. And when I say algebra, algebra just means you're doing equations, like solving equations, finding x, solving a system. And geometry is like when we start dealing with angles and sides and shapes and polygons. Okay, so that's really what we're talking about. All right, so for this one in particular, we have a triangle and we have a missing side. Now, what's important to note is that this triangle is what type of triangle is that when it has that kind of angle? A right triangle, right? So we will only use this with right triangles. So we can't just use this on any triangle, but as long as there's that right angle right there, we can use this. Okay, and the formula, you guys might remember this, is a squared plus b squared equals c squared. So that's a formula we use to find missing sides. Now, A and B, we usually call those the sides or the legs. Actually, I'll probably just call it the legs. And then C is your hypotenuse. Hypotenuse. Okay, so again, we're going to use it with right triangles. We got a squared plus b squared equals c squared. And since this triangle is not labeled, you don't have to do this every time. I could just give each side a letter. So I'll call this A, I'll call this B, and I'll call this C. All right, that kind of helps me set up my equation. All right, so I know that it's going to be a squared plus b squared, so 20 squared plus, there's the missing side. That's the one we don't know. You could put an x or a b or whatever. We just know it's the missing side. And then make that equal to c squared, which is 25. Okay, now I'm going to use Desmos for today, just because it's so useful. And the first thing we'll do is 20 squared. 20 squared is 400. And then we'll also square the 25. That's 625. Okay, and again, now we just continue on and solve it like an equation. So now here, I'm going to subtract 400 from both sides. That cancels out. We bring down the b squared. And now 625 minus 400, that's going to be 225. And now the key step here is the last step. The last step, we need to square root. Actually, let me just write out the full name there. So again, anytime we have that b squared or x squared or any type of squared variable, you would square root it to get rid of it. So square root both sides. And to do square root in Desmos, just type, there's a square root option right here. And that's 225. And so you can see the answer is 15. So b equals 15. That's the length of the missing side. Okay, so again, setting that we're using this equation every time, a squared plus b squared equals c squared to find the missing side. So that might be, you guys might be familiar with that, might remember that from middle school, but just a little review on that. Okay. So I'll come back to this in a second, but those are the problems you're going to see in Delta Math. So this is the Delta Math assignment for that's due tomorrow. And you'll get a triangle, looks just like that. You'll find the side, and again, all you need to do is type in that number for the side. Okay, you don't have to type in anything else like b equals or x equals. Okay, and then that's it. Okay, you could see they kind of point out that the side across from the angle, right angle, is the hypotenuse. They're setting it up the same way, except in this case, they called the 20b, and they set up, and they're looking for a. So it doesn't matter which one is A and which one's B, as long as you make the sides next to the 90, the A or B, okay? And as long as this one is the C, the one across from 90. So that's the most important part, is making sure that you're putting the side that's across from 90 set up as your C, okay? Now the second one doesn't give you a picture. There's no diagram, so you have to read it and then draw your own diagram. So here it says one of the legs, so remember the legs, that's the part next to 90, of a right triangle measures 3 centimeters. Okay, the other leg measures 14. Okay, so let's go ahead and set that up. So we'll say one leg is 3 centimeters. Oops, sorry, I meant to put leg there. One leg is, and one leg is 14 centimeters. All right. And then the last piece of information says find the measure of the hypotenuse. If necessary, round to the nearest tenth. So we may have to round it off. Okay. And it says find the hypotenuse. So that's the side we're looking for. All right. So if I set up this triangle, doesn't matter what it looks like, as long as you have one side, one corner that has the right angle. Okay. Now, one of the legs is 3, so it doesn't matter which one you label 3. You could do this one or that one. And notice how we have a unit of measure. We have centimeters, so we're going to include that. So that means that the other leg here is 14. And now we got to find the hypotenuse. All right, that's the side we're looking for. Okay, so we set it up the same way. We're going to set up the Pythagorean Theorem. So we'll say that's A, this is B, and we're going to find C. So we're going to do 14 squared plus 3 squared equals C squared. And I'm going to do 14 squared over here in Desmos. That's 196. I already know what 3 squared is 9. Okay, and then we just add these two up. So 196 plus 9, it's going to be 205, 205 equals C squared. Now again, just like the last one before, we're going to square root both sides. And when you square root, okay, that gets rid of this, that basically cancels out the little square. That's why we do that. Okay, now we're going to square root that, 205. So we're going to do square root of 205. Now notice, you guys got a decimal answer, 14.3. But it says round to the nearest tenth. Okay, so let's just write down to the nearest, we'll write down to the thousandth here. Okay, or actually, let's go all the way down to 10,000. Okay, so I'm going to write down 14.3175. 14.317, sorry, 8, not 5. Okay, now we need to round it. So So round to nearest tenth, because that's what delta math requires us to do. It's going to require us to round sometimes. So remember, 1/10, a tenth is the first number after the decimal. Okay, so the first number after the decimal is the tenth. If you guys remember how to round, I want to look at the number that's after that. So if I'm trying to stop there, I want to look to the next number, which is the 1. Okay, and if that number is 5 or greater than 5, that would increase the 3 by 1, but it's just 1, so it stays 3. So just a quick review on rounding. That's what you're going to be required to do in delta math. Okay, so if that was like a 5, let's say the 1 is a 5 or a 6 or a 7 or an 8 or a 9, then you would actually change that 3 to increase it by 1 to a 4. Okay, so here this would be 14.3. See if we got it right. It is correct. Okay. All right, so now that's Pythagorean theorem. So now let's move on to scale factor. Okay, so that's basically what you're going to be expected to do in the Pythagorean theorem for delta math. You'll have, for the second one, again, you're going to have to read and draw your triangle out. Okay, and remember for that one, you guys need to show your work. Okay, so now for the second folder here, scale factor, polygons. And I'm going to focus mainly on the worksheet and what's expected in there. And kind of how to go about that. Now, we already worked on scale factor last week, so you kind of learned initially how to do that. So we're going to use that same idea with these problems, okay? So I'm going to go ahead and I'll leave that there for a second. Copy that down. So here's a new problem. We just want to find what is the scale factor between these two shapes. Now, to do that, you simply take the scale factor, I'll write that here on the left. It's the new divided by the old. Okay, so a new side, or actually we'll say new side divided by old side. New side divided by old side. Okay, and you gotta make sure that they're corresponding. So we'll say need to be corresponding. I ran out of room there. Okay, so in other words, you got to find the sides that match the other side of the second shape. So if I'm looking at, let's say, the 6, and which side corresponds to the 6, well, that would be this side. But there's no number there that corresponds with 6. So I can't use that. Okay, if I look at the 4, that's the number on the bottom, well, that corresponds with 20. So those sides correspond. That's what that means. They're basically, they match. They're the ones that are the same, but obviously in the next triangle, they're bigger. Or on the 8 and the 40, these two sides correspond. Okay, so now I can use either these two or these two to find the scale factor. I don't need to use both. Okay, I'm going to go ahead and use the numbers on the bottom. So the scale factor is equal to, again, the new side divided by the old. So the new side is the one on the 20. Okay. Okay. And the old side is the 4. And when you guys do the worksheet, it's going to say, find the scale factor of the smaller figure to the larger figure. So you'll follow the same pattern. We'll take the larger one and divide it by the smaller one. Okay, divide these two, and I get 5. So the scale factor is 5. Okay, so that's pretty simple. You just take two sides, take the larger side or the new side, divided by the smaller one. That's it. Okay, another example. Let's say I got a shape that looks kind of like this. Again, I'm going to do my best to draw this thing. So here we're going to have 25, and that's the missing side there. And then 7 and 8. So we're going to be looking for that missing side. So I'll give you guys a second to copy that down. I didn't mean to do that. All right, I'm going to have to combine those videos. Okay, so here we're missing that side. So what we're going to do is we're going to set up what's called a proportion. Okay, we're going to use that same idea that these two sides are similar. Okay, so the missing side here and this side. Oops, I am so sorry. Don't copy that. This is supposed to be pink. My bad. Those are similar. And then I got to pick two other similar sides. So I'll pick the 5 and the 25. Those are also similar. Now, just in the same way that I found the scale factor, I'm going to set it up the same way to find that missing side. So I know here's my missing side, and you could call it whatever. You could call it X if you want to. So I'm going to call it X. And this time I'm going to put the X over the 7 because those sides are similar. And then I'm going to take the 25 and put that over the 5 here. Okay, the side that corresponds to it. Okay, so now all I have to do to solve this is I got to cancel out that 7. You guys remember problems like this from quarter 1. I multiply 7 to cancel it out. And I have to do the same thing to the other side. Now remember, when you multiply that 7, you're only multiplying it times the number on the top, not the bottom. So I'm basically going to do 25 times 7. So 25 times 7, that's 175. Number on the bottom doesn't change. And now I divide those two. 175 divided by 5. So I'm going to hit answer. Wait, no, I don't want that. So 175 divided by 5, you get 35. So X equals 35. So that's what this side is. The side that missing side is 35. And again, what I did is I just basically matched the X to the 7 and put those over each other. And then I matched the 25 to the 5 and put those over each other. Okay, and then once I set that up, I just multiply the number on the bottom here by both sides, and then divide those two to find that side. Okay, so we're going to do one more example. Okay, so now with these two triangles, I'm going to put this one and then this one, making this one just a little smaller. Okay, we're going to say this is C, this is A. We're going to label the corners. And then this is going to be E, D, and F. Okay, and what we know is we know that AB, side AB is 55, side CB is 65, side EF is 44, and what we're looking for is side DE. Okay, now we have a congruence statement. Move this up a little bit. And you're going to get a statement like this, and it'll say triangle ABC is similar. This means similar. When it just has the little one wavy line, it means similar to triangle FED. Or actually, it also means corresponds. Okay. So let's see. So I'm going to put that over here. This symbol right here means corresponds or is similar. Okay. Is that you need this congruent statement to figure out which sides are corresponding. So remember here, I had to match up with the X with the 7, 25 with the 5, or in the first one, the 4 with the 20. I got to figure out which ones are corresponding. And to do that, I have to use this statement. Okay. So it says that A goes to F. So if you notice, A comes first and F comes first. So what that means is that F and A are the same. But notice on the next triangle, F's not on the top. It's in the bottom corner. So what that means is what happened, we took this triangle and kind of like rotated it to where that corner is now here. Okay. So that means A matches F, B matches E, and C matches D. All right, so we are going to be looking for this side. So we need to find the side that corresponds to DE, or in this case, ED. Well, you look at the statement, it's the last two letters, E and D. So that means the last two letters in this triangle correspond. Okay, so ED matches BC. So that means that these two sides correspond. Even though the picture, it looks like, wait a minute, that's not on the bottom. It's because it's been kind of rotated. Okay, so those two match. You got to look at this part of it to see which ones match. Okay. Now again, just like this one, I need two sets of corresponding sides. All right, so there's my first one. And then I want to see, do I have a corresponding side to EF? Well, let's check it. Well, EF would match AB, and AB does have a side, right? 55. All right, so we'll use that. So it means EF matches with AB. Now we can just set it up the same way like we did before. I'll call this X, our missing side, just so that we have something to write. I'll put X on top and the side that matches it on the bottom. And I'm going to set that. And again, if I put the X on top, I also need to put the side from the same triangle on top as well. Okay, so 44 goes on top. And that matches 55, so that'll go on the bottom. Now the steps are the same. Just like I multiplied 7, here I'll multiply 65. And I'm going to use Desmos for all this because these are kind of big numbers. So it's times 65 on both sides. Sorry, that's a 65. That will cancel. And I'll show you how to multiply all that together in Desmos in one step. Sorry, it's a 6. So in Desmos, we're just going to do, first of all, 44 divided by 55. And then out here, I'm going to put times 65. So literally, it's the same thing, just like it was written here. Okay, so that's 52. Okay, so that's our missing side, X equals 52. Okay. So again, the key thing with all these is one, matching the correct sides. Make sure your sides are matching when you set these equations up, okay? And then here, when you get a statement, you've got to follow the statement. So if the first two letters match, then the first two letters match here, okay? Which also means that AC, because it's the first and the last, matches FD. So that means that this side, AC, would match this side, but you can see there's no numbers for us to use here, so that wouldn't even be something we could use, okay? All right, I'm gonna go and stop this recording.